Hey guys, so 12.4 talks about volume of prisms and cylinders. We already talked about what a prism is, what a cylinder is, when we did surface area back in 12.2. Now we're just going to talk about the volume of that instead. So where surface area was basically adding up all the areas of all the faces, volume is finding out basically how much space is on the inside of the solid that we're working with. Okay, so the easiest one is we're going to start with a cube. There's a special formula for the volume of a cube. Okay, a cube is a square prism, basically. So the base is a square, and basically all the sides are going to end up being the exact same length. Okay, so you can put a slashy everywhere. Okay, so if that's the case, if you have a perfect, like a dice, okay, just one of these sides is S, and all of the sides are the same. So that's a side length. And so the volume of the cube is just a cube of one of those sides. So side times side times side is the volume. Okay, now for any other prism, its area equals BH, and we're familiar with these terms, or these variables, I guess, a little bit. Okay, remember B is just the area of the base, and H is the height. Okay, so if you have, let's say, let's go with a triangle. Okay, if you have like a triangular base there, let's finish it off. Okay, it's like that pyramid, or that's not a pyramid, that's a prism. Okay, it's got a back here, right? It looks kind of like that. This one, we've got the area of this base is B, and the distance between the two bases is H. Okay, so that's what that would kind of look like. And lastly, volume of a cylinder. Once again, BH, but remember for cylinders we always have special formulas for those because we already know the area of the base is pi r squared because it's a circle. So pi r squared H is the formula you're going to want to work with. Okay, so that's going to look like, once again, oh gosh, that's horrible. Okay, we could do the front and back base again. With these, it doesn't necessarily have to be the top and bottom. Okay, so that's also a cylinder. Now you find the area of the base, right? The front is the base, and the distance between the front and the back is the height. That's it. I'll show you a couple examples. Okay, so we're going to find the volume of a right triangular prism with height 3 millimeters, and the base has a length of 6 and a width of 2.5. Okay, so this could look just like the one that I drew on the front. Okay, looks like that, and finish it just like that. Okay, the height is 3. The length of the right triangle is 6, and the width is 2.5. Okay, so we need to find the area of the base and the height. Well, we know the height is 3. The area of the base is 1/2 length times width. So 1/2 times 6 times 2.5 times 3. That's going to give us our volume. Okay, so plug that in your calculator. You get 22.5 square millimeters. Okay, number 2, we're going to work with cylinders. So I give you the radius, I give you the height. We have V equals pi r squared H. Okay, so I have R, it's 4. I have H, it's 13. So you don't even really have to draw it if you don't want to. You could just multiply it out. We've got 16 times 13, or 4 squared times 13. 208 pi cubic feet. Oh gosh, I did square meters. It's cubic meters and cubic feet. Okay, cubic units is what you use for anytime you have volume because it's a 3-dimensional space on the inside of the solid. Okay, number 3. We've got a rectangular prism. We give you the volume. All right, first of all, we know the volume. The formula is B times H. Okay, and the length of the base is 11 centimeters. We want to know if the width and the height are the same, what's the length? So we've got a rectangular prism. Okay, this box type thing. Okay, looks like that. Now, we have the volume, the whole thing is 396. We know the base, the length of the base, is 11. Both the width of the base and the height are the same, so they're both x. Okay, so how do we find the volume of this? Well, we've got length times width, right, for the area of the base. So the volume, actually we know the volume. You don't have to use that. We can actually use 396, because 396 is the volume. That area, that base, is 11x, and the height is x. So we have 396 equals 11x squared. We can divide by 11. That's 36. Take the square root of that. So we have x squared equals 36, or x equals 6. Okay, so 6 centimeters would be the final answer for that. And number 4, we have a cylinder again. Alright, and this cylinder has a volume of 277. I give it the height, I want to know the diameter. So remember the volume is pi r squared h, right? Well, we have v and h, so we can find the radius. Once we find the radius, we just have to multiply that by 2 to get the diameter. So 277 equals pi r squared times 5. So we could divide by 5 and pi. Okay, and we'll get r squared equals about 17.6 you should have gotten. Take the square root of that, and r equals about 4.2 feet. Okay, so if the radius is 4.2 feet, the diameter is going to be 2 times that, which is 8.4 feet. And that's it. Now, number 5 is a little bit more complicated. All right, we're going to work with concrete blocks. Okay, so a concrete block is going to look like a rectangular prism. Okay, just like that. But it's got 2 rectangular cutouts, right, holes throughout the block. Okay, if you've seen that before, you know what I'm talking about. Actually, that's a pretty good picture. I tell you, the dimensions of the block are 13.5 inches by 4 inches by 3 inches. Okay, and each hole is 3 by 6, so that's 6 inches, and that's 3 inches. All right, what we want to do is we need to find the volume of the block, and then we'll use this value right here to help us find the actual weight of the block. Okay, so the volume of this thing, we've got V equals the volume of the big thing, the whole thing, minus 2 times the volume of the small. Okay, because we've got the whole volume, this whole thing, and then we're going to subtract off these 2 holes. Okay, that's where that comes from. So we've got V equals BH minus 2 BH. Alright, well, the volume of the big base, or the base of the big base, the base of the big block is 13.5 times 4, length times width. The height of it is 3. And of the small ones, we've got the length is 6. The width is 3. And the height is, again, 3. Those holes go all the way through top to bottom. Okay, so we could just do this multiplication, subtraction. 13.5 times 4 times 3 minus 2 times 6 times 3 times 3. And we get the volume of the whole thing is 54 cubic inches. Okay, now with that, we've got 54 cubic inches, and it's 0.084 pounds per cubic inch, so the weight is going to be 0.084 times 54, which is 4.536 pounds per block. Okay, and that's all we got to do for volume of prisms and cylinders.